So we're going to look at the example code that we use for our tolerances problem in class. This is the one with the nieces and nephews that I have in the Excel table, and then we sorted it out for them being in high school or like middle school, elementary. I'm going to sort of walk through this code and show you what needs to happen so we can make things more clear maybe. So let's clear out our variables, clear our thing down there. I'm going to click run. And it's going to just stop and debug. So it's going out into Excel and just finding this file and it's pulling in these rows. You do not have to do that for the activity in class, but in this situation it worked. It is important to make sure that we do see the Excel file over here in the same spot. It's going to bring in all of those in numerical fashion right there, similar to what your tolerances are going to look like. I'm going to select continue. It's going to go here, and what we're doing is number of kids length, kids grades. It's going to this variable, and it's just counting all the items in it. So we have 10 different things, and so it actually plugs in that for the variable value. Then we're setting a value, sort of like what you'll have to do for your nominal weight, and then plus or minus at 9, and that way we can reference it to our logical comparison. Our next steps, we have our in high school there. Click continue, and here's where it compares my in high school to the kids in the grades. And so we're going up here to kids in grades, pulling in those values and comparing them to in high school, which is 9, and it gives me out a logical answer. So it's going to be 1 for yes, 0 for no, 1 for yes, and 0 for no. Then what I've done is I've gone through and I've summed all of those. So when I run here, it just sums it up. So it's counting in my high schoolers, it's counting how many ones there are. So we have 1, 2, 3. We're going to click continue now. It's going to do the same thing with little kids. So notice now I have another logical block here. There you go. We now sum those out. So that was the other 7 that are not included in the 10 is there. So we summed up those. So in here, we've gone 0, 1, 1, 1, 1, 0, 0, 1, 1, and so that is working. And then we summed it up. We then go here and we take the percentage, and so we've got our number under and our number over. So I'm doing under for some reason first. And so we've got under, which over here is 7. We're dividing it by number of kids, which is 10, and multiplying it by 100 so we get percentages. We do the same thing with our number over. And then we get down to the F print. And I think this is where kids get confused a little bit. And so if it's giving you issues with this ellipses, I would just delete that and just make it one big long line. But what an F print does is it like displays a string, and then whenever you have these percent signs and a letter, it goes and finds the next variable that's listed. And so when it's reading this, it's going to, you know what, let's just delete this here. We'll go click, 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 click. Make my parentheses. There you go. My comma. We're going to go F print number of little kids, and then we get to D, and it's going to go to the first spot. So right here, that is D. It brings in the decimal value of that. We move forward. We get to our next percent sign, which is the .2f, which is our floating variable. And what it is it's this right here. I should have probably used just my percent over, my percent under, but I didn't in this situation. It then sends that out, and the reason we have the double percent sign here is so it actually leaves the percent sign in, so it has to know that we're not doing something special with it for it to continue on. We click continue, and so we got number of little kids there, continue, and number of high school kids. So there is my output. When you sit there and you're doing this with your tolerances, with the candy, I would definitely try to break it down and make sure that you're getting this part right. In other words, are we getting the logical values for above that candy amount or below that candy weight to make it effective? Good luck.